Planet Earth. It is unique in our solar system. It alone harbors life. But our journeys to other worlds have taught us that neither Earth nor the life upon it can be separated from the events that created the solar system around us. Already our explorations have revealed amazing facts. On a battered moon lies the evidence of a force that shaped our planet. Beneath the hostile clouds of Venus may be the landscape of a primitive Earth. The red planet, Mars. Upon it lies the evidence of gigantic floods that once scoured its surface. Join us now on a voyage of discovery to the edge of the solar system and to strange new worlds that hold the secrets of our own creation. The story of planet Earth begins in space.
Major funding for this program is provided by the Annenberg CPB project. Corporate funding for Planet Earth is provided by IBM. IBM is proud to support the innovative spirit of scientific inquiry that made this series possible.
The Allen Hills of Antarctica, one of the most forbidding places on Earth. An unlikely setting in which to begin the exploration of our solar system. But in these bleak ice fields are clues to its earliest history. In bone-shattering cold and winds that reach 100 miles per hour, bands of scientists camp here each brief Antarctic summer. They come to scour the ice for meteorites, fragments of the solar system that have fallen to Earth. These tiny lumps were created by the same tumultuous processes that created the sun and planets. They are cosmic time capsules. Preserved in this colossal freezer, they tell a tale as old as the Earth itself. By analyzing this ancient material, scientists can reconstruct the events that created our solar system. Some 4.5 billion years ago, near the outer reaches of the Milky Way, a huge cloud of gas and dust begins to condense. Billions of miles across, the cloud collapses into a flat spinning disk, the solar nebula. Within the disk, particles collide and adhere, and the primordial sun and planets struggle to emerge. As the sun ignites, it blows away most of the gas from the inner solar system, and only hot, rocky worlds remain. Enormous collisions shaped the planet we will one day call Earth. Perhaps one last immense impact spins off matter that will become the moon. The Earth begins its slow transformation into the planet on which we live today. Four and a half billion years later, the Earth is still evolving. We inhabit a restless, shifting planet whose surface changes in endless cycles of creation and destruction. Most of the Earth's history is preserved in its rocks, but vast chapters are missing. The very earliest rocks, from Earth's first billion years, are gone. destroyed by its incessant activity. How can we know what happened on Earth before its restless geology erased the record? Our nearest neighbor in space was shaped by the same events that made the infant Earth. Might our long-dead moon hold the secret of Earth's missing history?
But if I were to say, my fellow citizens, that we shall send to the moon 240,000 miles away a giant rocket made of new metal alloys, some of which have not yet been invented, capable of standing heat and stresses several times more than have ever been experienced, fitted together with a precision better than the finest watch, carrying all the equipment needed for propulsion, guidance, control, communications, on an untried mission to an unknown celestial body, and do all this and do it right.
July 20th, 1969. Apollo 11 relays live pictures from the moon. Craters glide by. Are they extinct volcanoes? Or wounds left by still more violent events in the distant past? Ironically, part of the answer lies in rare moon-like regions of the Earth itself. It is not easy to see craters on Earth. Most are so eroded that only faint circular scars remain. But how were these strange structures formed? The mystery was solved here at Meteor Crater near Flagstaff, Arizona. A mile across and 600 feet deep, this enormous hole was created 50,000 years ago in an event of unimaginable force. Many scientists believe that Meteor Crater was the remnant of an old volcano. The real explanation involves a more radical idea, that bodies from space helped shape the Earth. Gene Shoemaker, a scientist with the U.S. Geological Survey, helped prove that the crater formed when a nickel-iron meteorite blazed through the skies and smashed into the Earth. The evidence was all around.
Well, the main evidence for the impact origin of this crater is in the geology. Some of it's right here underneath our feet, where there's a deep lens, 600 feet deep, of broken rock that was explored near the turn of the century by Daniel Moreau Beringer and his associates. And what we find is a deep lens of broken rock going to that depth, with the lower 50 feet containing the melted droplets of the meteorite, now frozen in shock-melted rock.
Collisions with Earth are extremely rare, but planetary geologist Pete Schultz has found a way to make his own. At the NASA Ames Research Facility near San Francisco, he uses an instrument called a vertical gas gun to reconstruct these great collisions. At 25,000 miles per hour, the gun fires metal pellets down a barrel more than 3 stories long. The explosions are recorded in extreme slow motion. These experiments reveal the forces that left thousands of craters and their explosive rays on the moon. Yet to read its real history, we have to know when the bombardments took place. And the moon's dark plains and ragged mountains, when were they formed? Until men walked on the moon, no one knew.
Fantastic! Percy Precision is Planet 1 on the plains of Descartes. Did we copy? A neat place.
As astronauts roam the moon's surface, their most important task is to gather samples of rock.
Look at the size of that rock. We can see. The closer I get to it, the bigger it is.
Most scientists believed that the moon's rocks would be ancient. Dating the lunar surface would finally reveal the early history of both the moon and Earth. They were wrong. Most moon rocks were between 3 and 4 billion years old, much older than those on the geologically more active Earth. But still, some 500 million years of the moon's history was missing.
Sound like a good guess.
The samples gathered so carefully were not part of the moon's original surface after all. It too had vanished like the Earth's in the remote past.
Dog, you did it.
As more samples were returned, the early chapters of the moon's history began to emerge. 4.5 billion years ago, the initial formation of the moon is complete. Its surface, heated by repeated impacts, cools. "4 billion years ago, a second massive bombardment may have occurred, destroying much of the original surface rock. For millions of years, lava wells up through the crater floors, hiding still more of the original surface. 3 billion years ago, the moon's surface solidifies. Except for a slow rain of impacts from space, it remains unchanged today. Our journey to the moon provided a surprise. Bombardments in space are not occasional catastrophes, but the most important force in the formation of planets. To explore these neighboring planets, we developed even more fabulous machines. Robots, sophisticated enough to travel millions of miles, were built. To scrutinize the worlds beyond, to land upon them, and to report upon what they found. The first planet we would visit was Venus. For millennia, man has seen Venus as a bright star glimmering on the horizon. Until recently, it resisted exploration. Scientists know Venus as our sister planet, nearly the same size and weight as Earth. Still, it remained a puzzle enshrouded in a mantle of clouds. Our voyages revealed it to be a most un-Earth-like place. Unlike the billowy white clouds of Earth, those on Venus are racked by storms and bolts of lightning. Thick and poisonous, they are filled with sulfur and sulfur droplets, an acid rain capable of dissolving the hardest of metals. At some levels, winds up to 200 miles an hour whip the clouds around the planet. And on the surface, the immense atmosphere creates a pressure 90 times more crushing than on Earth. No place can replicate the climate of Venus. No other world is as scorched and barren. No other landscape so charred and seared. But Death Valley on a hot afternoon can give us an idea. Venus has evolved very differently from Earth. How did it become the hot, desolate planet it is today? Jim Head, a planetary scientist at Brown University, is an authority on Venus.
Here in Death Valley, we find ourselves in one of the hottest places on the Earth. But it's nowhere near as hot as it is on the surface of Venus. Even though temperatures here in Death Valley on a really hot day can exceed 120 degrees Fahrenheit, on Venus, they get up regularly to 900 degrees Fahrenheit. In fact, it's hot enough on the surface of Venus to melt lead. How did it get this way? You might think it was because Venus, in fact, is closer to the sun than the Earth is, but it's only part of the answer. On Earth, the heat that comes into the surface can actually be re-radiated out to space again. On the other hand, on Venus, the very dense, thick atmosphere acts as an incredible greenhouse, a global greenhouse, which traps the heat underneath the surface of the cloud layer and builds up the heat over time.
Only the Soviet Union has successfully landed probes on the surface of Venus. Before they were destroyed in the hostile atmosphere, they radioed back images of a strange and hellish world. The pictures are extraordinary, but they tell us little about the geography of Venus. In 1977, America's Pioneer Venus spacecraft used radar to pierce the dense clouds, and Jim Head and his colleagues had a global view of the planet.
Now, the Pioneer Venus spacecraft provided information from an orbiter, which, using radar instruments, was able to provide a global topographic map of the surface of Venus. We can color the blues lowlands areas, as shown here. We can then color intermediate plains in greens, and highlands in yellows and browns and reds. When we look at this now, we can get a much better idea of the three-dimensional nature of the altitudes. And from this, we can begin to see areas such as lowland areas here that are like ocean basins on the Earth in terms of the low area, but of course, because of the heat on Venus, don't have any water in them at the present time.
But even these pictures are inadequate. Much of the Earth's geology would remain hidden if it were depicted in the same way.
Now, this is really interesting because all the familiar features, North and South America and Australia and the ocean basins, really look dramatically familiar. But when we look in more detail, we realize we have the same problem. The resolution isn't good enough to understand the nature of the geology. Something as dramatic as the Grand Canyon is just simply not visible at this resolution. So one of the obvious things is that we can really get a picture of the geography of Venus using the Pioneer Venus information, but we really have no idea what the geological origin of the surface features are.
To study the forces that shaped Venus, Jim Head and his colleagues use a very special tool. High in the Puerto Rican mountains near Arecibo rests the largest radio telescope on Earth. 1,000 feet across, this giant radar antenna bounces signals off the distant surface of Venus and scoops up the faint echoes that return. Though Earth-based, it is able to take an even closer look at Beta Regio than the Pioneer Venus spacecraft. Across 26 million miles of space, Arecibo senses details down to a single kilometer. At close range, Venus is still more astonishing.
Now, instead of a series of really vivid colors, what we see here is a lot of detail, which is really exciting because we can see right in the middle of the valley a whole series of bright lines which probably represent faults, and a large circular structure down here which has arms leading away from it. Now let's look at these in even more detail, particularly the area to the north. And we can see a lot of faults all the way through the middle of this extensive trough. This is very much like the setting in the East African Rift on Earth, where extensional forces are pulling the crust apart and faulting it into a deep valley. If we look to the south, we see that the circular feature is even more dramatic. It is a volcano which is built up on top of the faults, filling in the valley and sending lava flows extending away from the valley down the sides of the structure. So we can see here extensional tectonic forces, much like we see on the Earth, and volcanism associated with this extension, much like Mount Kilimanjaro is associated with the East African Rift on the Earth.
For billions of years, Earth has been changing. The process called plate tectonics is restlessly rearranging its surface, shifting its crust around the planet. But how did the process begin? Curiously, Venus may hold the answer. Looking at Venus may be a way of looking back across time at the Earth before the beginning of plate tectonics. Samples collected there may tell us even more. In a 5 billion-year-old Venus, we may be looking at a 2 billion-year-old Earth, an Earth as it was in its youth. Beyond Venus lies the red planet, Mars. Just 1/3 the size of Earth, the atmosphere of Mars is so thin it is barely there at all. The Mariner and Viking spacecraft revealed a world upon whose surface was written a violent and restless past. Across the Martian equator, they found an enormous gash, the Valles Marineris. 2 miles deep, it stretches the length of the United States and could swallow scores of Grand Canyons. Nothing quite like it had been seen anywhere in the solar system. Only in our imagination can we sweep through these great canyons, but future spacecraft almost certainly will. To the northwest of the Valles Marineris, Mariner 9 photographed an immense volcano rising 3 times the height of Mount Everest. 17 miles from surface to summit, it has a base as broad as the state of Montana, a place so majestic it is named Mount Olympus. Clearly, Mars is a world that works on a gigantic scale. We Earthlings have always found Mars intriguing, even before we sent probes to investigate. A century ago, we could only view it from observatories like this in the hills of Flagstaff, Arizona. But we speculated it might not be a planet too different from our own. We nurtured the ultimate hope that Mars, too, harbored intelligent life. Toby Owen is a scientist who studies the atmosphere of Mars.
Of all of the other planets, Mars is the one most often imagined to be capable of supporting some form of life. This is a book of drawings of Mars made by Percival Lowell, who built this entire observatory about 100 years ago so that he could study this planet in great detail.
Lowell described a world that fired the public imagination. Through his telescope, he made amazing observations. Each year, he watched the planet's ice caps wax and wane. During the Martian summer, he observed dark areas spread across the face of the red planet. These, he proclaimed, were the blossomings of Martian forests. Carefully, he recorded these changes in his notebooks. Vegetation was not the only kind of life Lowell saw on Mars. He believed it was the home of a desperate and dying race, one that had built a vast network of canals to carry water from its polar ice caps to the parched cities at its equator. As proof, he mapped an intricate system of Martian aqueducts and predicted that one day we would find the inhabitants of an ancient civilization. That is not how things turned out.
This is the telescope that Percival Lowell used to make his observations of Mars, the one through which he looked to make the drawings. Lowell was trapped on the Earth, as all astronomers were, until we learned how to send spacecraft to the other planets. When we finally got to Mars with the Viking project, we found a planet very different from the one that Lowell had imagined. No evidence of canals, no canal builders, no evidence of life of any kind.
From the pictures the Viking landers returned, it is not difficult to understand why we found nothing living on Mars. But photographs taken high above the planet reveal a different world. Locked in the ice caps of Mars are oceans of water, and once that water flowed across the Martian surface. Remnants of ancient riverbeds clearly reach out in fine finger-like patterns. Great scoured regions that resemble floodplains speak of a time when Mars was not always so desolate and cold. What could have created these strange features? The first clue came from Earth. The Scablands of central Washington state. 13,000 years ago, a 3,000 square mile lake covered much of Montana until it burst its glacial dam and roared across the Scablands. A wall of water 30 stories high exploded toward the Pacific to devastate everything in its path. In its wake, it left one of the strangest geological formations on Earth. Like great scars upon the skin of planet Earth, the Scablands remain, proof of the power unleashed by a catastrophic flood. Normally, these canyons and buttes would take millions of years to form. The flood gouged them out in less than a single week. From high above, the scars left by the Great Flood on Earth are astonishingly similar to the bizarre terrain of Mars. Billions of years ago, in flash floods that dwarfed those on Earth, liquid water must have rushed over the surface of Mars. Perhaps in the distant past, it was a planet much more like our own. If water was present on Mars, it may have harbored life. In Shark Bay in Western Australia, there are clues to what life on Mars may have been like. Here, organisms similar to those that flourished everywhere on Earth 3 billion years ago still live. They are stromatolites, rocky domes built by microbial communities. For more than 1 billion years, they were the dominant form of life on our planet. If Martians ever existed, they very possibly looked like this. But Mars lost its atmosphere and its water. The planet froze, and the thread of life would have been broken. Percival Lowell's desperate race of canal builders never did rule Mars, but if ever there was life on the planet, it was no less doomed. Mars marks the end of a boundary in our solar system. The last of the rocky inner worlds. These are the mysterious and faraway places we first visited. Each, like Earth, has taken a course of its own. Until we explored them, we never realized how much light they would shed upon the mysteries of our own tiny world. In these distant places, we begin to understand how deeply their past is connected with the past of planet Earth.